Okay, so in this problem here, you should pause it and take a moment to read that. This is quite involved. So he's going to ring the church bell 120 times in total, and the time interval, t, is between rings with 2 seconds. So if there's 120 church bells, there's 119 total rings, and here's the variance. And so the time interval t sub I for each one is independent of all the others, and x is defined as the sum of all the total time between the first and the last ring. And so another way to think about this is if I consider x is just basically the time of all these, and I know the expected value of x then is going to be the expected value of t1, which is 2, t2, which is also 2. Each of these expected values is going to be 2 of them, and in total there's 119, so it's going to be 119 times 2, which is 238. Similarly, if I look at the variance of x, well, it's going to be equal to the variance of t1 plus the variance of t2, and so on and so forth. And the variance I know is 1/9 plus 1/9 plus all the way up to this one. So in total, it's going to be 119 times 1/9, which is 119 over 9 is the variance. So x is a normal distribution with a mean of 238 and a standard deviation of square root 119 over 9 squared. And so there is our defined normal curve, our variance and standard and expected value. And so explain why a normal distribution can be used for an approximate model for x. Well, we know we have, so for B part, we know that we're talking about normal distribution can be approximated by x. Well, because our n is actually equal to 119, it's larger than 30, so therefore the central limit theorem will apply for this situation. We typically do the central limit theorem when we're talking about averages, but total time, total of all these, and averages are really the same idea, just one's divided and one's added. So now looking at C part, use the model to find values of A and B such that the probability between A and B is equal to 90%, where A and B are symmetrical about the mean of x. Well, if we draw this out, so I have a normal curve here where the mean is 238, and I'm looking for an A value and a B value where it's symmetric about x, the mean, and I want this area in the middle to be 0.9, which means that together these ends here have to be 10%. So one of them is 0.05. And so what I'm going to do in my calculator is I'm going to go inverse norm. The area I'm going to quote 0.05 because it looks from the left-hand side. And then I'm going to go a mean of 238, and the standard deviation is 119 over 9. And when I do that, I get 232 and change, but this value is 232 is the one I want. So A is 232. By symmetry, that's 6 values. So that's got to be 6 values. So B will be 244. And so I know that my values of A and B are 232 and 240. Okay, so now the hardest question of them all, I think. Okay, so in this last one here, we now know that the vicar believes that John is stopping to do it and that his buddy Ray is doing it. The only difference between John and Ray is that the variance is different. And so Ray has this scenario. So here's Ray. Ray is also normal, so it's 238. So I'm going to add up the 119 of them, right, times 2. And then there's 119 variances. And so it's going to be over 119 over 25 square root squared. This is the probability. This is Ray's normal curve. So Ray's normal curve. So to do good notation, normal, and it is Ray's. Okay, so now it says that the null hypothesis Ray is ringing the bell. So the null is that Ray is ringing. And so the alternative is that Ray is not, which means that it is John. So if I consider what's going on here, so if I'm going to test the null hypothesis that Ray is ringing, then I have a normal curve here of Ray's normal curve, and this variance is the 119/25. All right, and so he rings the bell. Now he's going to record 4 values of x to do the decision rule. If it's between 236 and 240, then he accepts H0. Otherwise, he accepts H1. So my boundary is going to be 236 to 240. And if I think about the probability of a type 1 error, and I know the question's asking for a type 2, the probability of type 1 error is if it falls in here. However, that's the type 1. That's the probability of rejecting Ray ringing when I should not have. Now, if I'm going to do a type 2 error, the type 2 error says I fail to reject this when I should have, which means John is the correct curve. Okay, that's an important statement. John is the correct curve. So I'm actually not testing that one. I'm testing this one here of 239 with my 119/9. This is the one that I am testing of Ray between 236 and 240. And the type 2 area is failing to reject, which is this area in here. And so I want to find the probability that x is between 236 less than equal to x less than or equal to 240. And that's going to be the type 2 error for one particular bell ring scenario. And so when I actually do this probability, I find this, I get a value that is, checking my answers here, I get 0.41, 0.41769. And that's, I would do a normal CDF from 236 to 240. The mean is 238, and my standard deviation is, because it's not actually Ray's curve I'm looking at, but rather John's curve. Now this is for one ring of 19 or 20 bells. However, the vicar is going to look at doing it 4 times. He decides to follow this rule. If he does it 4 times, then he will reject, or then if he does it 4 times, he will reject the null hypothesis and say Ray is ringing it. But this probability here is the probability of believing Ray rung the bell, where it was actually John who did it. Okay, and if I think this happens 4 times, because that's what the problem said, that's the first time, that's the second time, and so on. If this happens 4 times in a row, then I will, in total, fail to reject the null hypothesis when I should have. And so that, when I multiply that all out, I get 0.0304. And this is the probability of a type 2 error. That is a tricky. So to recap, the probability of type 2 error says I failed to reject the null hypothesis. I should have rejected it, but I didn't. So it means it's between these 2 values if I failed to reject it. If I should have rejected, that means John was ringing the bell. So this is the curve I'm actually looking at. So this is the probability of one instance John doing it, where I believe it was Ray, because it was in this region. But I have to do it 4 times, because the problem that it says is that he wants to do it 4 times in a row. So I raise it to the power of 4. I hope that helps. It's a tricky one.